Alright guys, good morning. At the beginning of the year, we learned a lot about parabolas. My pen is not working, really. Alright, we learned that anything that was a quadratic that could be written in this form would graph as a parabola, as long as it had an a value that wasn't 0. Now, we didn't do a whole lot of crazy business. We talked about the axis of symmetry a little bit, but other than that, we didn't talk about the actual properties of a parabola. Well, today we're going to learn about a parabola as a conic section. It's what happens when you take a cone here and you slice parallel to one of these diagonals. You get a parabola. But the parabola has some other definitions that make it very useful in the real world. Here's pictures of parabolas. This is one of the most important, is that when you have a parabolic satellite dish, this point is the focus of the parabola. Some of these other shapes have properties that deal with that as well. But the definition that makes the parabola unique, I'm going to come back to this, is that every point on the parabola itself is equidistant, or the same distance away from the focus point to the point on the parabola. Okay, if it was this point right here, we'll say this distance is equal to this line that is perpendicular to the axis of symmetry, and the same distance away as the focus is from the vertex. This vertex is to this line called a directrix. Well, that distance from focus to point on the parabola is always exactly equal to the distance from this point on the parabola to the directrix. Now remember, when you measure from a point to a line, it's perpendicular here. So those distances are always equal, and that's the definition. So it is all points such that every point is equidistant to a fixed point called the focus and a line called the directrix. So the distances in that picture over there, D1 and D2, are equal. Alright, so a vertical parabola opening up and down has an x squared, just like it always did. Okay? This is the focus. This is the directrix. And that directrix is going to be a y equals line. And what else do we need to know? We're going to have some other property here. This distance is p. So this distance is also p. And you're going to have an x squared, basically. When it opens left and right, the directrix will have an x equals equation, because it's going to be a vertical line. The focus point here, this distance is still equal to this distance, and it's called p. But you will have a y value that has the squared going on it. Okay? Now, we'll talk more about what those forms look like. But some properties you need to know. The focus point always lies inside the parabola. Okay, the parabola will open around it, curve around that focus. The directrix which is a line, make sure you have an equation for that, not a point, is always on the outside of the parabola, and the parabola will bend away from the directrix. The directrix and the axis of symmetry are perpendicular. The vertex is P units away from the focus and the directrix. Okay, it's halfway in between. The vertex is halfway in between the focus and the directrix, and that distance is P. And we're going to put that into our equation here in a second. Okay, this is an amusing one. I never taught this before, but it does help graph these. The lattice rectum. I want to say that too many times and make us giggle, right? Is a segment that passes through the focus with endpoints on the parabolic curve and has a length of 4p. There's going to be a 4p in our equation, and the lattice rectum is the line. So when you have a parabola and the focus point is here, if you were to draw from here to here, this total distance is going to be 4p. So it's the points on the parabola that line up with the focus make this segment called a lattice rectum. All right. So the standard form we are looking at, when it opens up or down, the form is x minus h squared equals 4p y minus k. All right? And it opens up as long as p is a positive number, and it opens down if p is a negative number. The 4p will tell you how far out these points are here, and hk will be the vertex. Now, when it opens sideways, this way or this way, then the y minus k is the squared quantity, and the x minus h is multiplied by the 4p. All right? The opens up if a is positive, p, sorry. And it opens left if p is negative. So, this is the sheet that you have on your reference sheet on the cardstock, and it says exactly the same things, okay? It does, remember, P is the distance from vertex to focus and vertex to directrix. That concept helps a lot. And the other thing that we could use is this lattice rectum idea that we're going to use today to graph. Okay. So it will help a lot if you just write the general form underneath, x minus h squared equals 4p y minus k. And I chose that one because the x is squared, so I knew which one I needed to write here. All right, so according to this, h is 4, 4p is 2, and k, it'd be negative 3. So if we solve this for p, we got to divide by 4, so we get p is 1/2. So The vertex is defined as HK on the reference sheet for this form, well, for any of them, but that means 4, -3 for this one. So we go over 4 and down 3, and that's the vertex. This one has an x squared, so it's opening up and down. The focus is 1/2 unit. Let's see, this was a positive 2p, so it's going to open up. And it's 1/2 a unit up to the focus. So if we go 1/2 a unit up here, it would be 4, -2.5. I'll just use a decimal. Now, the directrix is 1/2 a unit back this way, and it's a line. The directrix would be going down 1/2 a unit, so that would be -3 minus 1/2. It is a y equals line, so -3.5. The axis of symmetry goes right through the vertex. It's opening up, so it's cutting it in half this way. So that goes through the x value here. 1, 2, 3. Did I? No, I did. I couldn't count. X equals 4 is the axis of symmetry. Now, this is not a good example for how the lattice rectum can help us, honestly, because 4p was a distance of 2. So that means from the focus, if you go 2 this way, actually it's 1 this way and 1 this way. The whole lattice rectum is too long. So it's very tiny little parabola here. Okay. Very narrow. So the endpoints of the lattice rectum, the whole thing is too long, so it's 1 either way from the focus. So from the focus, if you go 1 to the left, you'll have 3. If you go 1 to the right, you'll have 5. And that's not on your reference sheet. What we've done in years past, I'll show you real fast, is we just picked a value and plugged it in to try to find a point on here somewhere. So if I went, let's try to find the y-intercept. Okay, the y-intercept would have an x value of 0. So I'm going to put a 0 back in here. I'm going to do the algebra a little odd to make it go faster. 0 minus 4 squared would be 16. Rather than distribute this, I'm actually going to divide it. You could distribute it, it's fine. And subtract, and I get 5. You don't have to do that. I'm not going to make you graph a lot of points because all of the questions on this, I believe, are matching. Delta Math might have you graph some, but not many. All right, y is 5, 1, 2, 3, 4, 5. So by here, this parabola would be that wide. Okay? And we could use the axis of symmetry to find another point over here. I didn't do a very good job. All right, let's see, it was 0, 5, 1, 2, 3, 4, 5. That just does not seem right. All right, I'm not drawing this well at all. There we go. Made it too narrow. All right, I'm sure you just fast forwarded through my painful graphing there. All right, go a little bit faster. This one is going to open sideways though, because the y is squared. So this time it's y minus k, careful, squared equals 4p x minus h. The x and the h always go together, and the y and the k always go together. So k is 1. 4p is -16, which means p is -4. The negative means it's going to open this way. And back here, H is 5. Now be real careful. It's still X, Y, H, K, so the vertex is going to be at 5, 1. Over 5 and up 1. All right. The focus, P is negative 4. So the focus is 4 units in the negative direction. And remember, this one was going sideways. So the focus is over here at 1, 1. The directrix will be back this way, 1, 2, 3, 4 points. So 4 added to the X value would be 9. The axis of symmetry runs through the focus and the vertex, so that would be Y equals 1. All right, now to graph the parabola, if we use this idea of the latus rectum, the whole segment, latus rectum here, is a distance of 4p or 16 units long. That means it goes 8 this way and 8 this way. So it's very wide. Because if we rewrote this in vertex form, it wouldn't be vertex form because we don't have, it's opening left, right. But if we divided the 16 over here, we'd have negative 1/16. Y minus 1 squared equals x minus 5. If we added the 5 over, we'd have 1/16. Y minus 1 squared plus 5. Remember when we had vertex form and a 1/16 meant it opened down and was very wide. The smaller the number, the wider the parabola. Okay? That's what's happening here. It's just going sideways. All right, so let's see. We went, what did we say, 8 units up and down from the vertex? No, from the focus, just kidding. So we'd be at 1, 9 and 1, negative 7. All right, now I do want to point out to you that all of these are following these rules right here, okay? All of this, you can find all the little formulas here to find the vertex when it's opening sideways. You take the H and you add the P. When you find the directrix, it's H minus P, okay? I'm just not using the little recipes. I'm using the concept, but either one is fine. All right, on one like this, they're trying to trick you because remember the formula goes x minus h equals 4p y minus k. So we need to put the 4p over on this side. To move that to the other side, we're going to multiply by a negative 4 times negative 1/4. We'll get rid of it here. And we're going to multiply this side by a negative 4 so that we have this form. And it will be x minus 2 squared equals negative 4 y minus 4. A lot of 4's here. Okay, so h is 2. 4p is negative 4, which makes p negative 1. And this would be k is 4. Now, this had an x squared, not a y squared, so it's opening up or down. A p of negative 1 means it's going to open down. The focus is going to be 1 unit inside. All right, so the center, the HK, the vertex, is 2, 4. It's opening down. The focus is 1 unit down from there. So that would be on the y, it goes down 1. The directrix is 1 unit up from there, but it is a line. So 1 unit up from 4 would be 5, and it's a y equals line. The axis of symmetry goes through the vertex, crosses the x at 2. Now to graph the parabola, you go from the focus point, which was here, at 2, 3, and the total length is -4 here for the total width. So we're going to go 2 either way, and that's plus or minus 2 on the x. So the endpoints there are supposed to be 0, 4. What did I do wrong? No, it's not 0, 4. It's from the focus. I went from the vertex. There we go. So it should be 0, 3. And add 2 would be 4, 3. And that just gives us a couple points to graph it. And again, most of these that you have to do are just matching a graph. On a summative, it's just multiple choice, okay? All right, so I think I'm going to skip this one and let you guys do it. But let's rewrite this form. Y plus 2 squared equals, to move this to the other side, you'd multiply both sides by 10, x minus 3. So you'd have y minus k equals 4p x minus h. So k is -2, 4p equals 10, which makes p 2.5, and h is 3. So the vertex is at hk. So much for letting you guys do it right. And it is a positive p-value with a y squared. Y squared means it's opening sideways. A positive p means it's opening to the right. Okay? So let me just show you the recipe here. If we just figured that all out, you're just using this. So the focus is at h plus p comma k, and the directrix is at h minus p, because it's opening sideways. So the focus is at 2.5 units inside this way, or h plus p, which would be 5.5, -2, and then the directrix is at x equals h minus p. So 3 minus 2.5 would be 0.5, because it's 2.5 units this way, and it's a line, so you need an equation. All right, and then the rest of it, again, you just need to know it's opening to the right. But if it's a total distance of 10 from this focus, it's 5 units up, 5 units down, and that's what the graph looks like, okay? Again, 4p is 10, and that's this entire distance is 10. All right, write an equation. All right, this is easier than it looks. It is opening down, so we have an x minus h squared equals 4p y minus k. The vertex is at, let's see, is that 1, 0? The vertex is at 1, 0, so h is 1 and k is 0. And p, remember, by definition, is really just this distance. So 1, 2, 3, 4. but it is opening down, so P is actually -4. So we get a -16. So x minus 1 quantity squared equals -16y. If you moved that over to the other side, you'd have vertex form. You'd have -116 x minus 1 squared equals y, because we're used to them opening up and down. When they open left and right, though, we have a little bit of thinking to do, but you just need the different form. The vertex is at, let's see, here's 0, 0, all right? 1, 2, 3, 4, 5, -5, -2. Let me count that one more time. Okay, so the vertex is at -5, -2, and the focus is at -4, -2. What we need is that P is a distance of 1 unit, okay? And it's opening to the right. So the form when it opens to the right or left is this. And if it's opening to the right, it's positive. So all we have to do is put those numbers in. Y minus -2, because that's K, squared equals 4P, which would just be 4, x minus -5, which will be plus 5. Writing equations from graphs is pretty easy. I think I'm actually going to let you guys try these too, and then I'll put them in the notes. All right, the other possibility is that they will give us this information. You could do a quick sketch. Left 2 and down 10, left 2 and down 9 is the focus. So that tells me right away it's opening this way, okay? So as soon as I figured out that the x's line up, so it's opening up or down, I know the form is, all right? And then if you really aren't understanding the concept, I can look right away and tell that these are 1 unit apart, and it's opening up, so P is going to be 1. But if you were confused, the recipe here, sorry, I should have this handier, for one opening up and down is that the focus, the vertex is HK, and the focus is H comma K plus P. So what you would do is you would say this is H, this is K, and this is H comma K plus P. So if K is -10 and K plus P is -9, okay, then you would add 10 over here and get P as 1. Which I understood from my picture. All right, so all you gotta do is plug everything in. H plus, or minus -2 is plus 2. 4P is just 4, and Y minus K. K was 10. Nope, -10, so it's plus 10. All right, let's see if this one lines up a different direction. Left 7, down 1. Left 10, down 1. All right, or you could just say this is H and this is K. This K value stayed the same. Without even graphing it, you could figure out that the K value is what stayed the same. So this one has a focus with the same K value, which makes the focus X value H plus P. Wrong way, sorry. So -10 equals H plus P. So if I add 7 over here to this -10, I get P equals -3, which actually makes sense because I plotted the vertex and then the focus was 3 to the left. So it's going this way, and this distance P is -3 because it was to the left. All right, so I just plug them all in, and it's a sideways one, so it's Y minus K. squared equals 4p, which would be 4, and I'd get negative 12, x minus h, which is plus 7. Okay. This one has a little bit smaller value here. This time the k stays the same. Okay, so k equals 8, h equals 2, and if the x value is changing for the focus, I'm going back to the recipe here quick. If the x value changes, it's this kind again, h plus p. Okay. Try to do this without sketching a graph this time, just to show you that you can. So 2 plus p is 7/2. If you subtract 2, this is 3.5 minus 2 is 1.5. Okay, use your calculator. And because it was the y value stayed the same, it opens sideways. I always sketch, guys. I just always do, so it makes sense to me. 2, 8, 3.5 over and up 8, so it's opening this way. All right, so when it opens sideways, it's y minus k equals 4p. What's 4 times 1.5? 6. X minus h. All right, given h and k. This time we're given the directrix. Again, if you sketch this, it just makes sense to me. You went left 3 and down 7, so you're over here somewhere. But this one went left 5 and is the directrix. So I can tell right away that p is 2. Okay? And it's going to open to the right, so it's a positive 2. But if you're not sure, you go back to those. Did I put it in here again? I did not. Okay, so go back to these definitions. Here, let me go back to the question. So what you have is an x equals directrix. That's going to tell you which recipe you're using. A directrix that has x equals is this guy over here. X equals h minus p. So you have x equals h minus p. Well, I know x is negative 5 when h is negative 3. So if I add that over here, I get negative 2 equals negative p, so p equals 2. So now I'm good to go. Now remember, it was opening sideways, so the formula is y minus k squared equals 4p, which would be 8, 4 times 2, x minus negative 3 or plus 3. All right, there's one more of those, and I'm going to let you guys do it and then check the notes. This has a Delta Math assignment. You can look at Khan Academy, but they don't have many practice problems.